Hello guys, good evening and welcome to today's live, you understand? So like I said, in today's life, what we are going to be doing mainly is more of preparations for our exams, you understand? And basically today we are going to focus on what? The topic, binomial theory. So like I said, this is one of the most easiest topic. Why? Because it's all about the knowledge and what's the foundations, you understand? So we are going to be going through each and everything you need to know about this topic, binomial theory. So if you are watching already, I would like you to drop where you're watching from exactly, you understand? I would like to know your location, and I would like to also know if you have heard about this topic before, you understand? So I don't know if you have heard about binomial theory before, but we are here to simplify it. So in the next 30 minutes, we are going to simplify binomial theory, and we are going to make your stay here awesome, you understand? So let's go. So now, the topic, binomial theory. So what it's mainly focused on, it's all about expansion of algebras, you understand? So now, and when you are expanding algebras, now let me give an example to back this up, you understand? So whatsoever we are going to be doing today, we are going to be taking it from the foundation down to the more advanced category, you understand? So let's start with the foundation. So now we're starting with the foundation of what? Binomial theory. And my first question is going to be something of this. So let's say we have x plus 2 all in the brackets. This is the power of what? 2. So now, this is my first question. And we are asked to do what? We are asked to expand it. You understand? So that's what the binomial theory mostly focuses on. So since we are asked to expand this particular question on the board, so we're going to be expanding it using just the normal multiplication format. But there are some questions that when it comes to multiplication, you can't do them that way because it's going to be very broad, you understand? So you just need to what? Know some of the formulas, and I'm going to be bringing them out one after the other. So let's go. So whenever you have something like this, so what you're going to do is that when you see something of this sort, this is that we should do what? Our x plus 2 multiplied by our x plus 2. So now this is just trying to tell you that when you're talking about the square of something, maybe a number, it simply means that particular thing times itself, you understand? So when you're saying this times this, so this is what we're going to be doing. We're going to be using this first value to multiply everything here. And we're also going to be using what? The second value to multiply everything that is what? Here, you understand? So now at this point, we are going to be saying our x in the bracket, we have what? Our x plus what? 2. You understand? Then I'm going to be using what? The second value, which is 2, to multiply everything we have here. So I'm going to be having plus 2 all in the brackets x plus what? 2. Hope you've understood up to this length. Now, we're going to say this multiplied by this, which is going to give me x squared. This multiplied by this is going to give me 2x. Then, multiplied by this is also going to give me what? 2x. Then the last one, 2 multiplied by 2 is going to give me 4. So from this place, I can then see that we have 2 terms in common, which is what? 2x and what? My 2x. So from this point, I'm going to have x squared. This plus this is going to give me plus 4x plus 4. So now, we have expanded this particularly, and you can see it's very easy to expand. So these are the easiest, these are most of the easiest ones. So we are going to be going to the advanced one, understand? So if maybe you solve before I finish solving, you can drop your answer in the comment section or any question, say. So now, let's continue. The next question says we should expand a plus b is power of 3. So now, if you know you understand this one per se, want you to drop yes comment in the live chat so I can check them up and know what you understand and the ones you don't understand. And if you have any question particularly, don't forget to drop it. I'm going to be going through your questions one after the other. You understand? So now, so the question says we should expand in the brackets a plus b raised to the power of what? 3. So this might look very tricky, but sincerely it's easy, you understand? You see the same format we are following for this particular one. So from this point, what we are going to do is to say a plus my b, then a plus b again, then a plus what? B. Why are we doing this? It's because we are talking about raised to the power of 3, and when we are talking about raised to the power of 3, it simply means you multiply the brackets in what? In 3 places. We are going to start with these 2 first, because we cannot multiply the 3 of them once. So starting with these 2. So we follow the same rule we did here. We are going to have a in brackets, we'll take everything a plus b, then we have this plus b in the brackets a plus b. Don't forget we still have something at the back. So now we are using this to multiply what? All this. I'm using this one to multiply what? All this. I hope you understand. Now from this point we are going to be having a times a, which is going to give me my a squared. Then this time this is going to give me ab. This time this is going to give me ab. And this time this is going to give me what? B squared. So from this point, what I'm going to be having is what? My a squared plus what? ab plus my ab is going to give me what? 2ab plus what? My b squared. So we now have all this. Let me put it in the brackets. Then we also have what? The last value, which is a plus what? B. So we're also going to be using this one to see what? Open what? These brackets. So firstly, let's use the first value to multiply everything here. We are going to be having a in the bracket a squared plus 2ab plus b squared. Close the bracket, right? Then we're having plus my b in the bracket a squared plus 2ab plus b squared. So you can see we're using this to multiply all this, and we're using this to also multiply all two. Understand? So now let's go. From this point, we are going to say this multiplied by this is going to give me a raised to the power of 3. Right? Then this multiplied by this is going to give me 2a squared b. You understand? Then from this place, we are going to be having this multiplied by this is going to give me ab squared. Then this multiplied by this is going to give me a squared b. Then this multiplied by this is going to give me 2ab squared. Then this multiplied by this is going to give me b raised to the power of 3. I hope you understand what I'm writing. I hope you understand what I'm saying. So now, I'm writing down part of it. So let me just wipe this part. So maybe I can write here. Now, I'll continue whatever we have here from this part of the code. So if you look at what we have here, mainly, you can see that this term, which is a raised to the power of 3, then we are having what? These 2a squared b, then we are having something that still have what? A squared b. So if you are adding this and this, then we are going to be having plus 3a squared b. You understand? Now, if you look at, we have used this, and we have used this. So if you look at this other part, we still have what? A b squared, and we have 2ab squared. So if you add this up, we are going to be having what? 3ab squared. You understand? Then we have our last one, which is what? B is about what? 3. So now, I hope I'm not confusing you. You understand? This is going to be very, very easy. You understand? So now, if you look at what we have here, there's something you will note: the coefficients. And what are those coefficients? If you look at this one, it has 1, this one has 3, this one has 3, and this one has what? 1. And let me tell you something. These coefficients we're getting from what we call the Pascal's triangle. So that's where most of these coefficients come from. So let me just illustrate just a little of the Pascal's triangle so that you understand what I'm saying. I hope you follow me. So now, Let me illustrate this Pascal triangle for you. Now, let's have something of this sort. We have 1, then we have 1, we have 1. You understand? Then from this point, we have 1, we have 2, we have 1. Now, let me tell you how they are getting this. This is the first one. Now, you just assume there's 0 here, for instance, there's 0 here. So 0 plus 1 is going to give me 1. 0 plus 1 is going to give me 1. But this 1 plus this 1 is going to give me these 2 guys here. Now, the same thing applies for this place. I'll put 1 here also. 1 plus 2 is going to give me what? This part, which is 3. 2 plus 1 is going to give me 3. And I have 1 here. So if you look at this, if you are talking about the fourth term, then this look exactly like this. So that's how this pattern came into what? Existence. Using what? The Pascal triangle. So I believe you then understand how to expand algebras. And this is just what? The basic aspects. That's the foundation. So I'll be checking the charts now to see your questions and also see if there's anything you want me to what? Reverse before we go to what? The more advanced stage. So let me check. So now, while I'm checking, just have thought I've written. So before I'll check, let me just continue. Let me continue from where I stopped. So now, let's go to what? Now, I'm going to be showing you something in today's life. Whatsoever we are doing here is going to be the format you'll be seeing questions in your test or exam, you understand? So I want you to give it your ultimate focus. And I'm going to be bringing in the energy so you understand more better, you understand? So now, let's go. So let me check out the chart. So, from this point we have what? We're going to what? Introduce what? Our what? Formula. And the formula says my t plus 1 is going to be giving us n k a n minus k b is above k. So this is the general formula for you to expand that are more broad, you understand? So when we're talking about you expanding, when I have something of, let me see, a plus b is to the power of what? 5. Now, when you start expanding something of this sort, you definitely make mistake. It's because it's too complex to multiply. Maybe you might be able to do it more. It's going to be too complex to multiply, so you make mistakes. So it's better we just what? Follow what? This is our formula that says t, k plus 1 is equals to my nk, a raised to the power of what? N minus k, b raised to the power of what? K. So that's the standard formula we are going to be using to answer most of the questions. So just hold it. So now, let's go. So we have a question here that says we should expand 2x plus 1 raised to the power of what? 4. So my question says what? I should expand 2x plus 1 raised to the power of what? 4. Now let me teach you something really quick. Now whenever you are expanding something of this sort, you should just note that you see this 4 here, this 4 you see here, this your 4 is not serving as what? Your n. What did I say? The power here is the one serving as what? Your n. You understand? So now let's input this into this formula. So whenever you are using this particular formula, you are going to be solving for each cases one by one. So we'll start from what? Let k be what? Equals to what? 0. That's what we're starting from. So if k is equals to what? 0, then 4 points, my n, which is already what? My 4. So in a bracket, I'm going to be having what? My 4, which is my n, then my k, which is what? 0. Close my bracket. Then I'm having what? My a. Now this a now is talking about this first term, which is 2x. So I'm going to be having my a, which is what? My a is going to be what? 2x. Then my b is going to be what? The second term, which is what? 1. Based on the formula we have. So from this point, I'm going to having this place to be 0. Then my a to be what? 2x. You understand? Then my n to be what? My 4. So everything here is going to be in the bracket. 4 raised to the power of what? 4 minus 0, which is 4 minus k. You understand? Then we have what? Our b is 1. All to the power of what? My k. And k is what? 0. So this part is for what? When k is 0. So you repeat the same thing. When k is equal to 1. So we are going to be having 4 here, my k here, which is 1. You understand? Then from this point, we are having 2x. We have 4 minus 1. You understand? Then from this place, we have 1 raised to the power of 1. Because we are using k as 1 here. Then we'll repeat the same thing. Then my k also will be equal to 2. So what I just going to be doing is that we will repeat this value till it gets to what? The 4 that we have here. So now let's continue. So from this place, I will start with my 4 and what? 2. Then from this point, I will still have my 2x, 4 minus 2, 1 is equal to what? 2. Then let my k also be equal to what? 3. So I have 4 and 3, and I have 2x, 4 minus 3, 1 is equal to 3. The same thing continue. My k should be equal to 4. I will have 4 and what? My 4, my 4 and 4. Then I will have 2x, 4 minus 4. Then 1 is equal to 4. So now we have bring out all the value of this. So we are going to be solving something now. So for you to compute this, which is 4 and what? 0, there's a formula we use. So in this particular formula, you have this part is always the coefficient of the term. You understand? This is always the coefficient, and that's what we want to get here. So we want to get this particular stuff which is here. There's a way to compute it, and the formula is that for me to get this, which is, let me write it as. So this is what it implies. So this is this. You understand? N choose k. So when it's like this, for you to get it, you're going to say your n factorial all over my n minus k factorial k factorial. This is the formula you're using. It says my n factorial over n minus k factorial my k factorial. Now we are going to be applying this here now. So now since we know our value of n as this upper part, then our k to be 0. So according to this formula, it simply means that if I'm to apply this formula here, then my n factorial is going to be what? What? 4. It's going to be what? 4 factorial all over what? Now my n minus what? K, which is 4 minus what? My what? 0 factorial. I have what? My k factorial, which is 0 factorial. So let me spell out what I'm saying. This is what? Factorial. Now, what it simply means is that when we talk about factorial of a number, it simply means you multiply that number from the point which it is to the descending order till it gets to 1. That's to say, if I have 4 factorial, it means I should say what? 4 times 3 times 2 times 1. You understand? Just be multiplying it from the number downward till we get to what? 1. You understand? So now let's go from the point. So from here, we are going to be having 4 factorial all over what? 4 minus what? 0, which is also going to give me what? 4 factorial. You understand? Then we are going to be having what? 0 factorial here, which is also going to give us 0. So from this point, 4 factorial divided by 4 factorial is going to give me 1. Because the both of them are the same. So 4 factorial is going to give me what? 1. So let's keep the value. Let's keep the value 1. So now let me keep the value. So I have what? My first value as what? 1. So this is where we are going to putting our values. Our value is what? 1. So we're going for the other one, which is k choose what? 4 choose what? 1. The same formula. We're having k factorial all over 4 minus 1 factorial, and we have 1 factorial. Because we're applying our formula, that's what I'm doing. You understand? So my 4 factorial is going to be over 4 minus 1, which is going to give me 3 factorial, and I have 1 factorial. So from these points, what you are going to be doing is that this 4 factorial simply means you can say 4 times 3 factorial, because if you continue from here, it's going to be 4 times 3 times 2 times, you understand? All over what? 3 factorial, 1 factorial. So from these points, my 3 factorial will cancel out this 3 factorial. Then my 4 divided by 1 is going to give me 4. So the second value is 4. So that's for the second value. So we're just going to compute everything. So we're doing for the other one, which is this. So see what? Our 4 factorial all over 4 minus 2 factorial. Then we have 2 factorial. So from these points, we are going to be having our 4 factorial all over 4 minus 2 is going to give me 2 factorial, and I have 2 factorial. So from these points, I'm going to be saying this can be given as what? My 4 times 3, you understand? Then times what? My 2 factorial. That's for the 4 parts. All over what? 2 factorial, 2 factorial. As 2 factorial, there are 2 now. So this one is going to what? Cancel out this one. So 4 times 3 is going to give me 12. 2 factorial is 2 times 1, so it's going to give me 2. So 12 divided by 2 is going to give me 6. So the value of this is what? 6. You understand? So that's that for that. So let's go for the other one. So we are solving for this one that have 3. So it's going to be 4 factorial, then 4 minus 3 factorial, then we have 3 factorial. So from this point, we are going to be having 4 factorial all over what? This is going to give me 1 factorial, then 3 factorial. So from this point, I'm going to be having my 4 factorial, 4 times what? 3 factorial, all over 1 factorial, 3 factorial. So now from this place, we are going to be having this can cancel what? This. So I'm going to be left with what? 4, which is what? The value of this one. Then the last one is what? We are computing the aspect of what? 4. So let's go. So we're going to be having 4 minus what? 4 factorial, then what? My 4 factorial. Based on our formula. So from here, I'm having 4 factorial over what? 0 times what? 4 factorial. So since we are going to something like this, it definitely means that everything must change to 0. Everything is going to change to 0 from this point. So there's no need to bother what? Solving something of this sort. So now let's see. Let's continue from what? This place. So everything here, which is 4, let me just make it easy. Then I have 0 factorial, then my 4 factorial. Sorry, this is going to be 4 factorial divided by my 4 factorial, which is going to give me 1, not 0. So everything here is going to be what? 1. You understand? So that's 1, not 0. That's 1. So now, since we have gotten everything we have here, because of the space is not that wide enough, the space is not wide. So we are going to just be clearing up this part and what? Putting in the values inside. So let me clear everything. So now let me put in the values. So in this place I have 1, then this dot just means times. Then I have what? 4, then I have 6, then I have 4, then I have 1. So those are the values I have. So now let me simplify what? The powers. So from this place, 1 raised to the power of 0, anything raised to the power of 0 is what? 1. So we are automatically getting this one as what? Our 1. Or just going to be raising some of the things here. So 1 raised to the power of 1 is also going to give me what? My 1. 1 raised to the power of 2 is also going to give me my 1. Everything here should just give me what? 1. You understand? So everything here is going to be what? 1. Let me just put a dot. So means multiplication. You understand? So hope you are following. Hope you are following. So from this place, we are going to be having this minus this, which is going to give me what? 4. You understand? Then we are going to be having this, which is what? This minus this is going to give me what? 3. This minus this is going to give me what? 2. This minus this is going to give me what? 1. This minus this is going to give me what? 0. So now, if you notice something from all this place, so everything multiplied by 1 is still going to be the same. So if you notice something from this point, this part is decreasing. We started it here from 0 to 4, but from here, it started back from 4 to 0. So that's just how it's going to be. So if you see it like this, you know that yes, what you are doing is working and it's the right way. So now, let's go. So now, from this point, we are going to be having 2 raised to the power of what? 2x, which is what? Going to give me 16x raised to the power of what? 4. Because 2 raised to the power of 4 is 16, x raised to the power of 4 is x raised to the power of 4. So from this point, I'll still have what? 2 raised to the power of what? 3, which is 8. Then 8 multiplied by this is going to give me 32 raised to the power of what? X raised to the power of what? 3. Then the same thing applies here. Then this is going to give me 4. So I'm going to be having 24 x raised to the power of what? 2. If I get 4 here, then 4 times 26 is 24. So from this place, everything raised to the power of 1 is still the same. So this time is going to give me 8x. You understand? Then from this place, anything raised to the power of 0 is what? 1, if you remember. So 1 times this is going to give me what? 1. So now we have computed everything we want to compute. And what we have fermented to is this men here. So these are the answers going to be like. These are the answers going to be like. From this place, we are going to be having 16x raised to the power of 4 plus what? 32x raised to the power of 3 plus 24x raised to the power of 2, 24x raised to the power of 2 plus 8x plus 1. So that's how the answer is going to look like. That's how the answer is going to look like. So if you see what we have, so when we finish solving all what we have to solve, that's we expanded 2x plus 1 raised to the power of 4. This is what we got as our answer. So if you know that when you're watching this, it was easy for you, you understand everything, drop yes in the comment section, you understand? And if you know you're just joining us now, please drop your location where you are watching from. And what we are going to do is to make sure we explain binomial theory in a more simpler and easier way, you understand? So we have finished what? With the basic, which is the foundation, which I said I was going to start from. Then I finished my foundation, then I've gone to what? This other part of it. So now I'm going to be checking the charts to see if you have any question before we continue. So stay with me, we are going to be taking on that question right now. And this one is going to be one of the most trickiest questions, like most students freak out when they see this kind of questions. And we are going to be solving it here. We're going to be solving it here. So let's see what we can do. Let's see what we can do. Let's continue. No waste of time. So I hope you guys are seeing. If you have any question, please drop it down in the comment section. There's no question. Hope the video is not clear now. Okay, the video is clear now. Okay. Mapping and function. Okay, I will do that. I've seen your message. Tijani Abdullahi. Mapping and function. I will do that. So now let's just continue. There's no time to waste. So, okay. From this point, we are going to be having what? Now we are going to be taking exam style questions. You see this one say? This is just where you just need to work. put your attention. These are the questions you will see in your exams, because the thing is that simpler questions do come outside in examples, you understand, but they give hard ones in exam, and that's what I want to simplify now, the hard ones. So let's go. If you look at what we have here, the question says find the fourth term in x plus 2. This is a very, very good question, you understand? Now, the question says what? We should know what? The fourth term in what? X plus 2 raised to the power of what? 5. So if I'm looking for the fourth term of this, we're still going to apply that same formula, if you remember. So the formula is what? T k plus 1 is equals to n k, we have a, n minus a, b raised to the power of k. So this is the formula. So let's take it. So from this point now, since they say we should look for the fourth term, you know that you're looking at this formula. This point here is supposed to be the one carrying 4, because we are looking for the fourth term. So this is supposed to be the one carrying 4. So if this place is supposed to be 4, then it simply means k plus 1 is going to be equal to 4. So the value of this k should be what? 3. You understand? Guys, for this k to be equal to what? The fourth term, which is 4 that we are looking for, we need to what? Replace this k here with what? 3. Hope you understand what I'm doing. So since I'm using my k to be what? Equals to what? My 3. I've got the value of k. And my value of n is what? This power here, which is what? 5. If you remember the result. So now say t, then my 4 is then equals to what? My n here is what? 5. Then I have what? My k, which is what? 3. Then from this point, I have what? My value of a, which is x. So I have x raised to the power of what? My value of this, which is 5 minus 3. Then my b part is what? 2. So 2 raised to the power of what? K, which is what? 3. So now let's continue from this place. What we are going to be having here is that my t, which is my fourth term, is then going to be what? 5 and 3. That's 5 to 3. Then from this place, I'm going to be having x raised to the power of what? 5 minus 3 is what? 2. You understand? Then you have times what? 2 raised to the power of what? 3. So now from this point now, we need to compute this, because if you remember the formula I say we normally use, it is what? Let me write the formula. Okay. N factorial all over n minus k factorial factorial. So this is the formula we are using. So let's apply this. So my n, 5 factorial over 5 minus 3 factorial 3 factorial. Applying the formula. So now from this place I'm going to be having 5 factorial all over what? This minus this is going to give me 2 factorial, and I have what? 3 factorial. So I can further break this one down to be what? 5 times 4 times 3 factorial all over 2 factorial times 3 factorial. So from this point, my 3 factorial will cancel my 3 factorial. You understand? So what I will be left with is what? 5 times 4, which is 20. 20 divided by 2 factorial, which is 2 factorial is going to be what? 2 times 1. So 20 divided by what? 2 is going to give me what? 10. So we are putting that part as 10. So my 10, my fourth term is going to be equal to what? Here, which is 10. And I have what? Times x raised to the power of 2 times 2 raised to the power of 3 is what? 8. So this time this is going to give me my fourth term to be equal to what? 80x squared. That's just simple. We are getting what? The answer for this question. So the question says find the fourth term in this equation, and we apply our formula, and that's just it. We are getting what? The answer. So based on what you have seen, binomial theory is not difficult. So now I would like to drop your comments down. If you understand anything, I want to see it in the comment section, so I'll know you understand, so that we can keep moving. Understand? I'll be checking your messages now. If you have any question, please draw back my attention so that we can sort it out before I continue. So now let me check out. So we are still going to be taking more questions. I have like 4 questions here before we end our class for today. But you see, these questions, they are very, very important, and they are going to be coming out in your exams. They are going to be coming out in your exams. So let's see. Let's see. So I can see your message. It's not clear. Let me see. Okay. So let's just continue. It's not clear now. It's clear now. I can see it's clear. So let's continue. So now, we take one really quick. So let's take another question very fast. And this how the question goes like, it says, find the coefficients of x squared if 1 plus x is equal to 5. So they say we should find what the coefficient of what x squared in this what expansion. So that's what we have to do. Now let's do that real quick. Like I said, anytime you're solving for this, most of the things you are solving, you will be applying that formula. And let us remind ourselves of the formula. I want you to learn the formula for today's class. It is t. Then we have our what? K plus 1 is then equals to, I have my n and my k, and in this point I have a, n minus k, b is equal to k. But that's just it. So that's the formula. So now, since we are asked to find the coefficient of what? Of x squared. If you remember what I told you that this part is mainly the coefficient. So since they say we should find the coefficient of x squared, it simply means that when we see this our k is going to be what? The 2. So we are going to be making what? Our s squared to be equal to what? Our k. So this power here is going to be the value of k. So whenever you see something like this, finding coefficients, the exponent of x is going to be the value of k. So the value of k here is 2. And the value of n here is what? N is what? My 5. You understand? So now let's continue. Let's just compute this because I just have to find the coefficients, not the term. So let's just do this. So we have our n and what? Our k, which is going to give me my n to be what? 5 and what? 2. So if I decide to compute this using our formula, if you remember the formula, it says n factorial over n minus k factorial k factorial. So from this point, I'm going to be having my n factorial to be what? 5 factorial all over what? From this point, I'm going to be having 5 minus 2 factorial, then my 2 factorial. So from this, I'm going to be having 5 factorial all over what? 5 minus 2, which is going to give me 3 factorial, and I have 2 factorial. So from this point, I can then break this down to be what? 5 times 4 times 3 factorial all over 3 factorial, 2 factorial. So when we have something of this sort, what you're just going to be doing is to say, 3 factorial will cancel out our 3 factorial. So I'm going to be left with 5 times 4, which is going to give me 20 over what? My 2 factorial, which is 2 times 1. So my 2 times 1 is going to give me what? 2. So I'm going to be having 20 divided by 2, which is what? 10. So the coefficient of what? X squared in this expression is going to be what? 10. That's just it. So the coefficient of what? X squared in this expression is going to be what? 10. I'll do a quick recap. What I said is that when you are asked to find the coefficient of any number, of any letter, like this in power, in binomial theory, what we are going to be doing is that we're going to be expressing what? Our x squared to be what equals to what? K. That's to say, the exponent of what? Our x is going to be the value of my k. then you remember our n, it's always what? The power of what? The expansion. So let's just continue. So now, these are kind of what? The coefficients. So if you have any question, drop it down in the comment section. And if you're just joining now, drop the location where you're watching from. So now let me check out the chart, see if there's anything answered. So let's continue, guys. So I still have another tricky question. Very, very tricky. Very, very tricky. This one. I'm not going to lie, this one is tricky. But we are going to solve it together. We're going to solve it together. So let's go. Let's go. So the question we have here says that find the term independent of what? X in x squared plus 1 over x all to the power of what? 5. So now if you look at the question says that we should find the term independent of x in what? This term. So before you say anything is independent of x, then that stuff should give a value of what? X to be equal to what? S should be raised to the power of 0. That's to be what? 1. If it is not x raised to the power of 0, then it is not independent of this. I repeat, for a value to be independent of x, or to be independent of x in this particular any question in the binomial theory, it simply means that since x raised to the power of 0 is 1, that value needs to have what? Power. The x power needs to be what? 0 before you can say it is independent. You understand? So now let's continue. Please, if you have a question, drop it. So let's continue. From this point, I have now let's apply our formula. The formula says our t k plus my 1. You understand? Then I have is equals to what? My n and my k. Then I have a n minus k b raised to the power of what? K. So this is the formula. This is the general formula. Just hold it. It's going to help you a lot. You understand? Let's continue. So from this point, what I'm just going to be doing is that now I have k t, which is in the base k plus 1 is equals to what? My n. The value of my n is here. I'm going to take it, which is the value of my n is going to be what? 5. Then my k, I'll just do it like this because I'm looking for what? I'm trying to check if it's independent. What is independent of x here? You understand? So now, from this place, I will have what? 5 and what? K. So in this part, I will have what? My a, which is what the value of this place, which is going to be what? X squared. All to the power of my n minus k. And my n is going to be what? My n is going to be what? 5 minus what? My k, which is not given there. So now, this other part, which is what? 1 over x. So from this place, I'm going to be having times 1 over x all to the power of what? K. So let me make this more simpler to understand. So we are going to be having this from this point. T k plus 1 is then equals to 5 choose k. Then we are going to be having x. Now, whenever we have something like this in indices, we are going to be using this to multiply all through here. So I'm going to be saying this times this is going to give me 10. This times is going to give me minus 2k. You understand? Then multiply by what? Whenever you have something like this in indices, that's 1 over x. It simply means that it is the same thing as what? X inverse 1. That's x raised to the power of minus 1. So from this point, I'm going to be having x raised to the power of minus 1 all to the power of what? This k. So if this minus 1 multiply this, so automatically everything here is going to be what? X raised to the power of what? Minus k. So now what we are going to be focusing on is not the coefficients, because I'm just trying to check which of this term is not what? Independent of what? X. So now what we are going to be doing is that from this point, we'll pick what? this out. And according to the rule of indices, when you have equal base, you are going to be what? Picking one of the base, and you are going to be adding the power when you have what? A multiplication. So in this point, we are adding the powers and picking one base. So we are picking what? Our x, and we have 10 raised to minus 2k. Then, if I say plus my what? Minus k. So from this place, I have my x raised to the power of 10 minus 2k plus minus is minus k. So from this place, I'm going to be having x raised to the power of what? 10 minus 3k. Now, if you remember what I said from the onset, for me to say this is independent of x, then it should be what? X raised to the power of what? 0. So since x raised to the power of 0 is the same thing as this, I want to check now. If x raised to the power of 0 should be the same thing as this before it's going to be independent, it's going to be like this, x raised to the power of what? 0. And according to indices, when you have something like this, s is going to what? Cancel this with x. You are going to equate the basis. Then you continue with what? Solving the power. So now let me continue. So let's continue. So now my power is going to be what? 10 minus 3k is then equals to what? 0. You understand? So if I finish solving, I'm going to be having my 10 is equals to what? This is coming here, 3k. You understand? So from this place, I will divide this with 3, and I will divide this with what? 3. Then my k is going to be equals to what? 10 over what? 10. Do you understand? So this is what? The value of what? My k. So now, from this point, since when we are finished solving and we have what? This particular value. So it simply means that if you look at what we have here, this what is not what? Independent. It's not what? Independent of what? X. So now, when you see a question like this next time, so these are to what? Solve. So I'm getting our k value to be equal to what? 10 all over what? 3. So that's how to solve something of this sort. So I'm just going to be taking the last question for today before we round up. And so I'm going to check in the live section now. If you have any question, drop it down so we can sort it out before what I continue with this one. So this is going to be the last question for today, and this is a little bit tricky. I'm going to drop it. If you know how to solve it, just start solving and what? Also drop your what? Answer in the comment section. I want to see it. So I've solved something of this before. So the question says we should expand. Should expand what? Our x plus 1 over x is about what? 4. So now, the reason why I want to solve something of this sort is that this needs to look a little bit confusing for most students. I understand. It's look a little confusing. Why? Because it's having what? A fraction. But now let me just make it a little bit easier for you. This thing is same thing as what? Saying x plus what? My x is equal what? Minus 1. Or it's equal 4. So I've changed it from being a fraction to analysis stuff. And from here we can keep solving. So now let me check. Let me check if you have any words. Please drop your questions down. Please drop your questions down before we continue. So I hope you guys are understanding what I'm doing. So I've seen the message. I should drop questions on mapping and function. I will drop them. I'll drop a video on that. Then we also have here. Okay, thank you. Let's continue. So let's take this question really quickly. This is the last question for today. So, and we have what? Our formula T k plus 1 is equals to n choose k, and we have our what? A n minus k, and we have our b is about what? K. So now this is our formula, and we are asked to expand this. So if you remember the way we solved the first question, we did for each term, we did the value of k to be equal to 0, and it got to what? 4. So but those of you that didn't watch from the beginning, let me just explain that again here. So now, from this place, we are going to be having what? Our t. So we are going to be solving for each term one after the other from this point. So first of all, I'll say let my k should be equal to what? 0. So if my k is equal to 0, from this place, I'm going to be having what? My n here is going to be what? Equals to what? 4. So for the first part, I'm going to have 4 and 0. My A here is the same thing as what? X. You understand? X and times. So X here, then I'm having what? The value of what? N minus K. So my N here is going to be what? 4 minus what? My 0. Then my B here, which is X raised to the power of what? Minus 1. All to the power of what? My K here. And my K here is going to be what? 0. You understand? So now let's continue the same format. Let my K also be equal to what? 1. So the same substitution, I'll just say this is 4 and this is what? 1. This is 4 and this is 1. Then I have x 4 minus 1, x minus 1 minus 1. So we're just applying the formula. K to be equal to what? 2. I have 4 and 2. X 4 minus 2. Then I have x minus 1. 2. The same thing applies here. K is equal to what? 3. I have 4, I have my 3, I have x 4 minus 3, I have x raised to the power minus 1, and I have 3 there. So the last one, K is equal to what? 4. I say you are going to be doing the value of K for it to get what? To the value of this n. So we are having 4, 4, we have x 4 minus 4, we have x minus 1, 4. So that's that for what? This. So let's compute this real quick. The first time we solve for this particularly, understand? So let's just get the values without wasting our time. So if we use the Pascal triangle, we are going to have something on this one. We are going to have 1, we are going to have 2 here, we have 1 here. And from this place, I'm going to be having 1, I have 3, I have 3, I have my 1. So that's how it's going to continue. But I might explain with this stuff, you might not understand what I'm doing. So let me just compute this again, the way we did it the first time. So from this place, what I'm going to be having is that from this point, value of this is going to be given to me as what? As my what? 1 when I compute it. So let's solve for this part. So my K, choose what? 2, which is going to give me 4 factorial over 4 minus factorial 2 factorial. You understand? So I have my K factorial over 2 factorial 2 factorial. So from this point, I'm going to be having my 4 factorial, which is 4 times 3 times 2 factorial, all over what? 2 factorial, and I have 2 factorial. So from this point, I'm going to be having this to cancel this, I'm left with 4 times 3, which is going to give me what? 12 over what? 2 factorial, which is 2 times 1, is going to give me 2. So the value of this here is going to be what? 6. We're just going to be replacing each value here. Just going to be replacing each value here. So the value of this first one is 1 when we finish solving. And the value of this second one is what? 6. So now let's continue. So from this place, if you see, we are, let me just continue the Pascal triangle. This and this is going to give me 4. This plus this is going to give me 6. Then this and this is going to give me another 4. And I'm going to be adding the last value to the 1. So that's just it. I wanted to just write it out so you can know how the Pascal triangle goes. You understand? Let's just continue what we're doing. So say 4 choose what? 2. So I did the other part. We have done for what? This part. Okay, this is what we did for. Sorry. We did for this part, not for this one. So the value of this is that 6. So that without wasting our time, we can get the value of the rest from this Pascal triangle. Because it's raised to the power of everything here is what? 1, 2, 3, 2, 5. And we're getting to what? 1, 2, 3, 4, 5. So this is how it's going to be like. So the first one is going to be what? 1. The second one is going to be what? 4. The third one is going to be what? 6. We have 4. Then we have 1. So if you compute everything here, this is what you are going to be getting. If you do the same thing I've done for the first ones. So this is what you will get. So now let's continue. The way we normally do it, my 4 minus 0 is going to give me what? My 4. You understand? My 4 minus 1 is going to give me what? my 3, I'm just going to change the values. My 4 minus 2 is going to give me my 2. My 4 minus 3 is going to give me my 1. Then 4 minus 4 is going to give me 0. Like I said, if you look at what we are doing, it's going to come from 0 to 4 here, and it's going to come from 4 to 0 here. So let's continue. So this time, this is going to give me what? X to the power of what? Minus 1 times 0 is going to give me what? 0. Minus 1 times 1 is still going to be what? My minus 1. Minus 1 times 2 is going to be what? My minus 2. And minus 4. You understand? So we are getting what? The value of all this. So let's just what? Multiply and see what we get. So from this place, we are going to be having, from here, I have a value of what? X raised to the power of 4 multiplied by this. So x raised to the power of 0 is what? 1. At x raised to the power of what? 4. Then for this other place, let's compute and see. Then this thing is the same thing as you saying 1 over what? X. You understand? 1 over x. Let me just wipe this out and do this. And do this. So we have 1 over x here. So let's multiply. This is going to multiply everything straight here. So I'm going to be having 4x raised to the power of 3 all over what? I'm not going to be having an x. Do you understand? Because it's not a fraction. So everything here is multiplying the numerator. Then I have this down here. You understand? So 1x is going to cancel x, and I'll be left with what? 4x squared. So from here, I'm going to be having what? 4x squared here. That's for this part. Now the same thing applies to this one, but this other part. So from this point, I'm going to be having my x squared times what? 1 over what? X is equal to 2. So from this point, I'm going to be having this time is going to give me x squared over what? My x squared. So if you divide 2, it's going to be giving you what? Just a normal 1. So multiply by this, I'm going to be getting what? My 4 here. You understand? So I'll follow the next step to continue with this other part. So now this is going to be what? My 4 times what? My x here. Then I have what? X is equal to minus 3. I hope it's not becoming more complex, and I hope you understand what I'm doing. So the same thing applies here. I will have 4x over x is equal to what? X is equal to what? 3 here. So now, I have it here as this value of 1. Then if I apply this thing here, everything here automatically is going to give me. So let's just do for the last part. I'm going to be having x raised to the power of 0, which is going to give me 1. And I'm going to be having x raised to the power of minus 4. So from here, I will just have my x raised to the power of minus 4. So now, that's how to what? Compute for what? Questions of what? This sort. Understand? So we have solved most of the questions that we have here. And we have seen that most of these things in binomial theory is not that difficult. And it's something that you can literally do and solve. You understand? I'm going to be checking the comment section now to see for your questions before we round up with today's live. So let me go through the comments. So that's it. We have come to the end of today's live, and I hope you understand what we have been doing here. So that's going to be all for today. And for more tips like this, subscribe to our channel as your Mentories, and we'll see you in the next one. I remain inspired, and that will be all for today. Bye.